All right, today we are diving into one of the most important principles for writing code that doesn't fall apart as it grows. We're talking about the open/close principle. It's a game changer for building software that's flexible and easy to maintain, and we're going to break it all down.
So let me ask you something. You've got a piece of code. It's working perfectly. It's tested. It's out in the wild. And then you get a request to add a new feature. Do you get that sinking feeling in your stomach? That little bit of fear that just by touching this stable code you might break everything? Yeah, if you know that feeling, you are definitely not alone. It's a classic developer nightmare. But the good news is, there's a design principle that was literally created to stop this from happening. And that is exactly what the open/close principle is all about.
Okay, so let's get right into the heart of it. What exactly is this principle? We'll kick things off with the official definition and what it's trying to achieve. Here it is, in all its glory. Software entities should be open for extension, but closed for modification. Now, I know, that sounds kind of academic, right? But it all boils down to two words: extension and modification. Getting the difference between those two is the whole secret.
This breakdown makes it super clear. Closed for modification is simple. If it ain't broke, don't fix it. Don't crack open code that already works. But open for extension means you still have to be able to add new functionality. The whole point is to add new stuff without having to mess with the old stuff.
Theory is one thing, but a great analogy is what really makes an idea click. So to really get the open-close principle, we're going to use a super powerful mental model, the good old socket and plug.
I want you to imagine that the core of your software system is like an electrical socket. You know, the one on your wall. It's stable, it's reliable, and it offers a standard way for things to connect and get power.
This is just a perfect illustration. The socket is your stable system. It's closed for modification, right? You don't call an electrician to rewire the whole house just because you bought a new phone. The plug, that's your new feature. It's built to fit the standard. And when you plug it in, you've just extended what your electrical system can do without changing the wiring one bit. In the world of code, this magic is called polymorphism, and it's the engine that makes the open/closed principle work.
See, that analogy just works. So let's take that idea and see how it actually looks in code. We're going to do a classic before and after, taking some code that violates the principle and transforming it into something beautiful.
Okay, here is one of the most common violations you'll ever see. Picture a payment processing system. The bad way, the fragile way, is to have one massive function with a giant if-else-if ladder, or maybe a switch case, that checks for the payment type. You know, if type is credit card, do this. Else if it's PayPal, do that. You get the idea.
And here's where it all falls apart. What happens when your boss says, hey, we need to add crypto payments? Well, you have to go back into that file, add another else if, and modify a class that was working just fine. This is so risky. You could accidentally break the credit card logic, and now you have to retest the entire massive function all over again.
And here is the beautiful transformation. On the left, you've got that brittle if-else chain. Every new payment type forces you to change it. But on the right, that's the good stuff. That's the OCP-compliant design. Instead of that big conditional block, we have a core processor that doesn't care what the payment type is, as long as it follows a standard rule or an interface. So now, to add crypto, we don't touch the processor at all. We just create a brand new crypto payment class, a new plug, and our system just knows how to use it. We've extended the system while the core logic stays closed and safe.
So we've covered the how, but now let's talk about the why. Why should you even bother with this? What are the real-world benefits? And maybe more importantly, are there any hidden traps you need to watch out for?
The payoffs here are huge. You seriously reduce the risk of introducing bugs into your working code. Your core system stays stable and reliable. Adding new features becomes, dare I say it, easy. You just add new classes. This also means your testing costs go way down because you only have to test the new piece, not the whole system. You're basically creating a plug-in architecture where new functionality can be snapped in, just like plugging a new lamp into the wall.
But, and this is a really important warning, after hearing all this, you might be tempted to slap an interface on every single class you write. Don't do it. That's a classic trap called over-engineering. Piling on abstractions where they aren't needed just makes simple code way more complex and a pain to read.
So that leads us to the most practical question of all. When is the right time to actually use the open/closed principle? You want to invest the effort in places you know are going to grow. It's perfect for parts of your system where you expect a lot of change, like adding new kinds of reports, or new discount rules, or, like in our example, new payment types. And a massive red flag, a huge signal, is when you see that same kind of if-else or switch case checking on a type popping up in different places. That is your code literally screaming at you for an abstraction.
Okay, let's switch gears. To really hammer this knowledge home, we're going to do a quick, rapid-fire Q&A. These are the exact types of questions you're likely to get in a job interview or on an exam.
First up, the most common one. You're looking at some code and you see a long if-else-if chain that's checking the type of an object. Does this violate the open-closed principle?
Yes. The answer is almost always a definite yes. And why? Because to add a new type, you are forced to go in and modify that existing block of code. That is the literal definition of an OCP violation.
All right, let's level up a bit. There's a well-known design pattern called the strategy pattern. Does using that pattern help you create a design that follows the open-closed principle?
Absolutely, it does. The strategy pattern is pretty much the textbook example of OCP in action. It's specifically designed to let you plug in new algorithms or behaviors, new strategies, without ever changing the main class that uses them.
So, after all of that, if you only remember one thing from today, please let it be this one. Simple question. Anytime you're about to add a feature, just look at an existing class and ask yourself, to add this new functionality, do I have to open this file and change its source code? If the answer is yes, you've probably found an OCP violation.
And that's our final thought for you. The next time you sit down to add a feature to your project, just pause for a second and ask yourself that question. Your answer is going to tell you if you're building a fragile system that gets weaker with every change, or a resilient one that gets more and more powerful with every extension.